as I think all of you are as excited as I am to listen into knowledge graphs for metadata and lineage. And the title basically is, this is more about information governance, while metadata kind of sits at the core of it. Basically, the idea behind is how do we basically use knowledge graphs, or how over a period of time knowledge graphs have changed. Basically, how do we manage, govern the data and data into information and information to knowledge. So the journey basically has been for last couple of years. Basically, I've seen evolve knowledge from data. So this is about data management, data governance, information governance, and how do we bring this all together, and knowledge graphs and Grakn, how they have played a part into this. And just as I start this session, basically, I'm I'm not going to focus on a lot of engineering problems in this session, basically, which is deep down saying how do we code and all that stuff. But I'm going to cover some of the business problems and basically how knowledge graphs gonna help solve these kind of scenarios. Very quickly, I'm not sure how many people know basically from which background we come from and what is the kind of scenario. So I work with a company named Infosys. For people who who have not heard of it or scenario, we are an IT services company, uh, about 35 years old now in business. And our main focus basically is to enable digital services for our customers. And just to put a bit of focus on our priorities, basically, about one-fourth of, or one-third, nearly one-third of revenue comes from digital and data. And that is a practice basically which I work with, which is we call as data and analytics. And we are about half, $1.5 billion dollar unit within Infosys, focusing primarily on data and analytics. And as part of that, basically, I'm one of the senior architects working with the practice. Data management and data governance is something, an area of my interest, while I do consult some of our large customers on their data architectures, data strategies, and data management and governance strategies. So that's a brief about the company. So something basically which we have been seeing in market right now are a lot of focus on data basically. And what we say basically, today's organizations need prompt answers, uh, and at every moment of truth. When I say every moment of the truth, basically it is about at every event, basically, if I need to have an answer. So if I'm a retailer and there is a strike in one of the countries which is part of my supply chain, what is the impact on my warehouse management today? Am I going to fulfill my orders to the stores, or do I have, if there is a delay on shipment, what is an impact on it? So all those events basically which are happening, each of them are the moment of truth, and there are different, the organization needs those answers. And some of the, I think these are a lot of buzzwords basically which I've put in there basically, but these are the things basically which organizations are working on: hyper personalization, digital channels, new revenue models, etc., etc. But what's basically, it's all, if I kind of divide it into some of the benefits or the key objectives for the organizations, they're looking at improving their customer engagement or improving their stakeholder engagement. They want to bring operational efficiencies, whether it is in terms of cost, in terms of making processes lean, faster time to market, straight through processings, etc. New revenue models, and a lot of these revenue models are driven from data. So how do you monetize your data? How do you use your data better? How does tech and data drive your new offerings basically? So there is a lot of this new revenue models which are coming along, and there is a lot of focus coming in terms of regulatory and compliance. So being in Europe, GDPR is something basically which has got attention, and a lot of organizations working around that. And these are now these are all basically kind of data problems, information problems. And most of the organizations, if I start driving their business visions, business focus, I'll be able to kind of bracket into one of these four. Obviously, there will be more, but these are kind of scenarios which most of the organizations are working upon. The challenge basically, and there are several challenges, but from a landscape challenge perspective, one of the challenge basically which organizations are facing to achieve these objectives is they want to be data driven, but they might need to make their decisions data driven. But the complex systems, the proliferation of data. So if I go basically in a typical uh, mid-sized bank, a bank which is in a country, at least you'll have about 500, 600 systems which are working. Some of them are mainframe, some of them are mid-modern, some of them are on cloud, some of them are on premise. Every company at this point of time either is about to start building a cloud data warehouse, for example, or a cloud data lake. And then there is a data lake which is there in Teradata's, Netezza's of the world, or the appliances of the world. There are data platforms basically which are, they've started 5 years back, they started investing into Hadoop data lakes and Hadoops, etc., etc. And there is a lot of proliferation in terms of how data is being computed. A lot of interfaces, on-prem, cloud, legacy, modern, APIs which have come into place. So overall, there is a compute proliferation. There is a data proliferation. And this is all going across multiple systems, right? Multiple systems on-premise, on cloud. And then there is the advent of, in banking, it came out to be open banking. So your systems are not only limited to basically what your organization has, but you are talking with marketplaces, you're getting orders from marketplaces, you're getting invoice finance requests from marketplaces, and several things which are external system. So if I look at this flow of data within an organization, it is across technologies, across hosting solutions, internal, external, and it's extremely complex. What it does basically, what it makes it difficult for organizations basically is one, the anything which we need to change or run within an organization is extremely complex and costly, because you know where to change, how to change, if I need to rationalize, what I need to rationalize, where do I need to rationalize, what gets impacted. So the understanding of this entire landscape in order to make a change is very complex. And to run it also is complex and very high in cost because of those technologies, because of the number of players in this ecosystem. And it's very difficult to rationalize because it's a running engine with so many things. It's not basically easy to go and rationalize all these scenarios without knowing the exact impact of that. The other aspect of this basically is this brings very a low understanding of the data which we hold. So if I don't know if I don't know, I don't know, right? So if I don't know what data my organization holds, or what data basically the organization needs to consume, or what data is available on a particular platform versus another platform, if this data is same as the other data, is this data, does this data augment the other set of data, or basically is these are just duplicate copies of data, I can use it from wherever, and where should I use it from, which is more authoritative copy, and all those kind of scenarios. So it's a very complex thing for us to know basically where the data is and how do we get it. And probably I'll be preaching to choir if I say, most of the data scientists and people who are data scientists, 80% of the time they spend in actually collecting the data and finding where the data is, what data I should be using. And 20 to 25% time they use in actually building models, making sense out of the data and all that kind of scenario. So if I don't know my data, what data my organization holds, I'll not be able to consume them or monetize them. And the other aspect basically is a low trust in data basically. So if I don't understand this data really well, and I don't trust the data, I know there is data, but I don't know whether it is accurate or not. Is it 100% of the is it 100% of the data which my organization hold? Or if this is if I'm holding a customer information, is the address correct or not? If I'm running demographics, I don't have confidence on the recency of that data, I'll not be able to trust that kind of data. So there are trust issues with the data basically, which are there. And then basically, it becomes very difficult to manage some of the regulations. So if I go into banking world, there are regulations which are proposed by BCBS where I need to have the lineage of the data. So if I'm publishing a number to the market, I need to know, trace back which process, when the data was generated, where it mapped to, and all those kind of scenarios. If I take GDPR, if as a customer, if I go and say, you know, I, I want to know this organization, what data you hold on me, I need to exactly know where I hold my customer data, in which all systems, which is collected from which all channels. So typical CPG company, if it has basically multiple brands, they will have these like 500, 600 micro brand sites. They might collect data of all of them basically. That is just one aspect of the business, but there are 500 touch points where customer can give you data. If you don't have a trace of my customer data within my systems, I don't know where the data is, and the customer has right to know what data we hold as an organization for them, or if they say basically my data should be forgotten, it should be erased, I need to know where that data is. And if I don't know where the data is, I cannot adhere to that regulation. You know, so currently basically I can still go and do a manual one. Somebody puts up a request saying my data should be forgotten. I can raise a ticket basically and I can start figuring out, okay, I have a request. Now I need to start erasing the data. It may take 2 months to actually figure it out, right? But if I don't know where the data is, and if I know it automatically, I can cater to that request more efficiently. And as these regulations become more popular and people are more aware of their rights, privacy rights, the number of requests, such requests an organization will get will increase, right? The other example, basically, I was talking with one of the leading banks. So one of the shipping companies went bankrupt in China. They wanted to know what the exposure their customers have. But within their data, they could not figure out basically which all contracts have an exposure to this particular company which is going bankrupt. It took them about 2 months to answer that query saying which customers will get impacted because a particular company in China is going bankrupt, right? So those are the kind of problems basically, and this is not a regulatory issue, but this can be a regulatory issue in a different scenario. So it becomes very complex problems for the organizations if they don't understand what data they hold and where they hold to actually adhere to some of these regulations and all. So, so just to basically, so this is what I wanted to say basically is what the problem we are trying to solve or what is the problem statement. Most of our customer, being a services organization, a lot of our customers face similar problem. Banks have this problem. Retailers or consumer facing organizations have this problem with regulations and with basically engaging their customers better. The people who are in retail customer business or a commercial business, they want to engage their customers better. The pharmaceutical companies have a different scenarios. We heard a lot about yesterday on clinical trials data and how the clinical trials happen. They need to know the entire lineage, every process and all. So these are the problem statements. Every industry has their own flavor of these problems. So what is basically our kind of a solution? And this is something basically which is closely related to Heckle's yesterday's keynote when he was opening this one, saying, can I actually connect to the information? Can I get all this metadata in some intelligent manner and bring it to kind of a central place where I know basically I have a mechanism to get this data? Second, basically, can I observe this data, which is more around, you know, bringing this data in a format basically where I can start making some sense out of this data. Then I actually sense and analyze this data, which is about, if I draw parlance to yesterday's session from Hackle in terms of, can I actually do some automated reasoning on this data? What does this mean if the data comes in with changes? Can I make some change to that? And then I learn and respond basically. So whatever I've observed, can I actually make what I've learned out of it, and how do I respond? And then can I make a sentient interaction? When I say sentient, it means basically which a way a human can make an interaction. So the example I was earlier talking, if there is a strike which has happened in, let's say, Taiwan, which disrupts a supply chain for a manufacturing company or for a retailer, for example, there are several people who get impacted by that. So there is a warehouse management team which knows that their order is not gonna, their shipment is not gonna come. There are stores basically who need to know basically they're not going to fulfill some of these things. The e-commerce business needs to know that there might be delay in some of them. The financial people need to know that there is some financial issues around that. Things, there will be different kind of people who need to know in a different forms and shape. So how do I actually make sentient interactions with them? That's basically is, how do I enable them basically? That's a key. And with the current set of technologies we are having, this is something basically which is more possible now than it was probably 3 years earlier on when we started. And what we call basically, and we are not solving the entire problem in this session, but what we are trying to solve in this session basically is what is the metadata aspect of it, and what, if I collect this metadata, what all these problems I can solve, and how do I solve. And that is something basically which we as in within our company, what we call it as unified information governance, because we are bringing information from multiple places and trying to uniform it in one single place. So what does the reference architecture, or what does it look like, the what do you say, documentation which has gone into your EIM systems, configuration management systems, and things like that. And there is a lot of this compute hairball, basically I call it a compute hairball, where different systems, technologies are running the compute things. And with the advent of cloud and with the advent of big data, the things are basically, I have Apache Atlas doing its own things for, there is Cloudera Navigator which has come in place. There is Azure Data Factory which has come in. There's Azure Data Catalog which has come in. There are several such areas where we are on an agile journey, where we are doing things basically because we need to cater to business. And all these basically compute engines are springing up everywhere, which are taking data from A to B and doing some processing, some business rules built into that. All these are basically metadata generators, and we cannot rationalize it. So I was having discussion with one of our next speakers who's gonna speak on similar topic. I was saying basically, he was saying basically, I want to put up a standardization across all my 50 data engineers. I'm saying you might be able to put standardization across all your 50 data engineers, which are part which you can influence, but there are silos, factories which are running along with sitting with the business, sitting elsewhere, and all those things. So some part of problem will get solved by standardizing the processes, and some part of the problem needs to be solved by basically how do we actually connect this data in an intelligent way, bring it together, and make some sense out of it. And then basically if I move down there are data quality exceptions. So I'm doing data quality checks everywhere. I'm doing data quality checks when I'm loading data into my data lakes. I'm doing data quality checks when I'm at my compute, at my edge computing points, and things like that. And if I move further, basically, there are a lot of data discovery tools basically I've started putting in. I've started writing business glossaries. I've started in implementing Waterlines, Tammer of the world, where I'm trying to automatically detect basically what this data means. I'm associating my data with the business glossary using some of these tools. And if I move to the far, this is IT asset directory. So what systems I run, what host I run, what are my business applications, um, what ETL compute processes it uses, what are the processes, which data sets it actually have, kind of scenario, right? So these are few examples, and this information I can keep adding. I was not able to put it all on one single slide, but what are the solution for that basically is one, standardization. Second basically is building a lot of bots basically which start collecting those metadata in some kind of a common template and bring it into some common place so that we can start making use of that. And some of the places this has been very successful where we have built some of these bots, right? You build some 100 plus, 120 plus bots to go to Oracle SQL, to go to Informatica, go to Ab Initio, go to your configuration DB to start collecting this metadata. And these bots needs to run wherever these systems are and bring it together. The second aspect basically is how do I observe this information? That is where the knowledge graph comes into play. Basically, how do I start making sense out of it? So what business applications, how they are linked to the tools, how those tools are linked to the processes, and how they are linked to which network they are running, which host they are running, and and then start bringing business glossary together, technology the technology glossary and the operational metadata aspect of it bringing together, and then bring basically what is, when I actually ran a ETL load from A to B, what were the exceptions which happened? What is the data quality which happens? Now, if I attach data quality to this and I have metadata, I know because of a particular problem in a particular run of a batch process, what are the outcomes basically which are going to be impacted? Because I have the technical metadata, I have the operational metadata, I have the business glossary, and I have the data quality exceptions all linked up in a graph, in a network. I know what is an impact of A to B. I could have done it without the graph as well, but graph kind of brings that shortcut because now I have that knowledge, it brings that kind of a shortcut. And the second aspect of this basically is actually making sense out of it, right? So sense, analyze. So this is basically, so graph gives you that obvious view. And then basically how do I sense, analyze, learn, basically, which we call it collectively as a digital brain, saying based on certain things as the data flows in, how do we actually learn and how do we actually respond to this scenario? And then there are several use cases which you can run with this. So there can be data stewardship, which can happen. There is data governance metrics, which you can generate. There is asset management, which we can do. We can make a data marketplace. So basically where data scientists come, basically now since we have all this information brought together, this can create you a data catalog and then a data marketplace which says, I need this data, where do I bring it from? And I'll talk about some of these use cases further down in scenario. And I can basically look at events, alerts, and saying, based on this, what action? So if I need to do any kind of event action scenario, which will go and build that. So that is basically is a very simplified view of the architecture. Obviously, there are the other complexities and technologies running behind it. But for now, let me focus on basically, since we are talking about knowledge graph and basically how an example of a knowledge graph and how it caters to few use cases. That is what I want to cover. So if I go next, basically this is, it's not very readable from there, but let me try to see if I can. So this is basically a part of that knowledge graph. And this is basically, this is what we call as an assets knowledge graph, or an assets part of the entire knowledge graph. It's not the entire schema, which starts with, say, for example, business organization. So business organization is something like retail or logistics or things like that. And it says, who are my business applications? So in that, basically, I may have a marketing data warehouse, I have a retail data warehouse. And I say basically what is a application instance. So I have 4 instances, one for Europe, one for Middle East, one for Asia, and one for Americas. So what is my application instance? This application instance works with which all software platform. So this is not a hierarchy, but I'm just trying to explain that. So what software platform it uses? Informatica, Tableau, which comes, Informatica Power Center, Tableau, and it all comes from. What is a software server platform? Basically, the software server platform is a physical installation of that. And what is not there is, there is host, basically, which host this platform is implied on. And then if I go down, what is a software server capability? Some might be having ETL engine and all that stuff. And if I go further down, basically, what are the processes which run on it? So if it is a ETL, basically, there is mappings, workflows, batches which run. And if it is Tableau, then there is workbooks, sheets, and the worksheets and the data analytics, etc., running on it. If it is, let's say, an analytical app, basically it's an app, and basically within the app there are several set of pages and all that stuff. And then basically it goes in terms of on the other side of the network, saying what are the business application, what data stores it has, what those data stores have, what data sets have what data fields, and then what these data fields basically how they are impacted by the process. So if you look at this, basically it's, and there are a lot of details which I have now not shown on this one for the purpose of, but if I go through this storyline, so from applications to data fields, and from physical infrastructure to tools, etc., and this all brought together, and it caters to all the knowledge which we need to try to bring together in a knowledge graph. And some of these, all this information basically what I talked earlier is what we try to get via bots. So I have basically for one, if I have built this basically for one of the banks, where we have actually went into IT infrastructure crawlers, which goes to every host and say which applications I have. Then basically you go into their configuration DB, or what they called as their enterprise information management portal, where we had list of all the IT services which they run team support, all the sets of business applications. And then we went to Technopedia, and Technopedia said, this is the description of all the tools which you have, or the standard names. We did a bit of a data cleansing, one-time data cleansing for them, and brought them all together. And this is kind of an automated feed which comes in. And then we actually went into metadata generators, Ab initio, Informatica, uh, the Spark processing they had, and the Atlas they were using for configuring, and a couple of them basically to bring the data set kind of a lineage. Two separate part of the projects which we did. But this is a automated way of bringing this information into this graph. And basically and this is one part which is we call as enterprise assets and data sets, and then there is a data quality aspect and the operational aspect of this graph, which basically we are building. And what we are exploring now, just before I move on, what we are exploring now is basically an open standard platform, ODPI edge area, which is a standard way of how a knowledge graph for information governance can be modeled. There are full-fledged services, open source services, they provide APIs and all. What we're trying to see basically is our graph model actually goes and aligns with their graph model and the thought process. What it gives us basically is a lot of interoperability in the exchange of metadata if we need to do in future. So this is the core graph, and this is kind of part of the graph. And basically, how does this benefiting different personas within an organization? One of the CIOs basically were helping him to say basically what is my modernization strategy and how can I optimize my change and run cost for an organization. For a leading coffee chain in US, basically one of the CDOs, basically they are a global chain, even though they are headquartered, they are affected by GDPR. So they wanted to understand basically how do I be ahead of curve on my GDPR regulations. Then basically as a customer, I talked about I need to know what data an organization holds on them, right? And as a data owner or a data steward, basically I want to know what is the health of my data in my data domain. So if I am responsible for customer data for commercial banking in a bank, how's a commercial banking customer's data health is there, where I'm capturing, how the master data managed for that. If I'm a business support person, and this is something which we are doing for a mutual fund company, they wanted to say basically my frontline support, the business support, as soon as basically they used to support a lot of data platform reports, etc., etc. So if the number is not coming well in report, the first line support then starts looking why is this number not there. So if I know basically the impact of whatever data quality issues happened when the data was loading, if they already know that these are the reports which are going to be impacted, the time basically in which they can respond to the business saying there are problems, hold on, we are trying to fix it, uh, uh, versus basically, yeah, this is a problem, this is how it will get fixed, and this is the time it get fixed. The amount of time they do on investigations, how can we bring that down? And then basically, the data scientist problem, basically what I talked about basically is what data do I hold? I want to do XYZ analysis, give me all the data sets which I can use, right? So there is a simple aspect of saying, give me all the customer data. So what we are helping one of the customers based on this reference architecture is basically helping them build a data marketplace. So actually basically where people can go search saying, recently last week Google released 25 million open data sets. So if you look for Google data search, they have launched a data marketplace where you can get publicly available 25 million data sets. So similarly, basically they're building for their internal line of business, and they're trying to build it for all their subsidiaries. So they're a conglomerate of multiple banks. So they have data sets basically which they internally want to share with their data scientists, as well as with something basically which with their subsidiaries, and some of them with their customers, not an immediate focus, but something with their. So what basically they want is to enable their data scientists with a data marketplace which is searchable, and they can have a recommended set of data sets. So if you choose let's say, a, a post-sales data or a sales data, then basically they can actually get a recommendation saying, a weather data might be actually useful and this is lying somewhere here. If you want to use it, basically this is kind of a recommendation for them. So that is, so these are few personas, these are not all the personas or not all the use cases, but these are some of the examples basically where a need for a unified information governance comes along. And what I want to do basically going next is a little bit more deep dive into one or two use cases and demonstrate what part of knowledge graph and how it has helped. So if I take the CIO case, which I was earlier talking. So the CIO problem statement was I spent 75 million annually on 400 plus tools in my data landscape, right? Sure. So in my data landscape, and how do I actually optimize this? Basically, can I bring this 400 to a valid number down? So can I bring this to, 60 possible tools? So I have 5 tools which I'm having in data visualization. I have 6 tools which is an ETL one. I have 5 tools which is for data analytics prep and things like that. So how can I rationalize that? So what they want to understand basically is what is a business case for rationalization. Again, we can't read it, but they want to know basically what are the tools, what is the license cost, what is the number of users, which lines of business is using, whom do I, if I rationalize this, how much run cost I can save, how much operational cost I save. And basically whatever graph part which I showed earlier, this is a detailed part of that. So this basically says now saying what the example I was earlier talking, retail sales has a software platform which is Informatica. Under Informatica, they have an instance, an application instance, which is the BI application UK. BI application UK runs off this particular server. This particular server has a Power Center ETL tool which is there. If I go down, this is for Tableau. And then basically for particular ETL tool, for that Informatica Power Center, what you see in red is the processes. So what are these processes, right? No specific analytics, just bringing this information together. We were able to give him at least within 3 to 4 weeks, we were able to give him at least business case for 5 tools, right? Out of 400, not entire 400, but out of 400, 3 weeks to do a business case for 4 tools, which itself is an, if you think it's quite an achievement given the size of an organization. It's a global bank operating out of 60 countries, talking to different people, could have been really 6 instances of business objects, 5 or 8, I don't remember the instances for ab initio and all those kind of scenarios. And with those business cases, we said demise 2. And demising 2, basically one is 3.5 million annual license cost, one is 2 million annual license cost. So 5.5 million savings is what a business case you can generate. It will not help you. This is the business case part of when you actually start demising them or rationalize them. Basically, this will give you that baseline inventory of what to rationalize, how to rationalize and all. So this is one use case and how knowledge graph can cater to that. The other use case basically is for CDO, which I talked about, the GDPR part of it. So if I look into this graph, if I go and further drill down, so if you remember we talked about data sets, right? In this example, what I have taken is I have taken email ID as an example and said, where all do I have email ID in my systems? So if I take email ID, all my top, it's not very readable. All those reds are the business applications. All the green ones, all the blue ones are the data sets where I'm holding them. And all the green ones are the data columns. And the yellow ones are the tags associated with them saying this is a. With one search, basically if I manage my metadata well, with one search I can trace the entire path for all the elements which are tagged as PII or SPII. And PII, SPII is a data field tag. So if I put a right query in Grakn, I'll be able to trace where exactly my link is. And all this data basically is fed again by the bots, basically, which are taking data from my ETL processes. So in this case, it was an Informatica mapping which it deciphered and said basically, this is my source target pair of of the data. And then basically, this is since one of our CDOs didn't wanted to interact with basically a graph DB in person, they wanted to put up a portal, and this is something which we have created an additional visualization. This is simple stuff based on D3JS, talking using Grakn Quill at the backend to extract the data and put it into D3JS and making it a little bit more interactive. And similarly, basically, there are multiple other ways basically we can do this. So the one of the ways basically what I'm showing here is one of the partners we are trying to work with is Solidatus, which is doing a lineage view specifically for regulatory requirements like solvency, like Basel, CCAR in US and all those kind of scenarios. And this is in exploration way. So which makes sure basically we present an information in a way basically which clears off the regulators. The second bit basically is a Cdo dashboard or a data governance dashboard, which we are trying to build, which we already has. And I think we're short of time, but this is, okay. So this is one of that outcomes basically which has gone into Tableau and basically which says, you know, so this is what I was talking about basically if I forget all those things. So I said there were a set of ETL issues when the ETL processes were running. And if I look at these ETL processes, there were 3,500 incidents which were logged, rows which got exception. And these were the top n number of reports which got impacted because of this data quality. So when I was talking about that business support scenario. So if I bring that metadata and I bring the operational metadata and I bring data quality together, I can tell business support or business saying because of those issues, what is the impact. And it doesn't stop at that. It also tells you basically what is the dollar value in suspect. So what metrics, what value went under suspicion. And then basically since you have all the granular data, you can go into, you know, all the slice and dice of it, saying which application, which source I should fix, whom I should call, and if these are repeated processes and all those kind of scenarios. So we did a word cloud based on the search, whatever we added. We also uploaded the incidents data, the quality exceptions data from ServiceNow basically and ticketing systems. And we did a text search for that, basically a text search results shown there saying what are the typical set of problems basically have been reported in that. So this is basically a consumption pattern basically, right? So let me just stop here. I think I wanted to show a few more examples. So the data marketplace and some of those data marketplace scenarios which I talked about. So how Grakn basically helps is when we have all this data set information, this is very searchable in terms of by system, etc. And you can draw some inferences out saying, how do I derive a weather data set and a post-sale data sets are linked that is based on those inference rules, some of those scenarios. So I'll take a pause here basically and for